Good morning, class, and welcome. What we're going to do today is review some of the material we covered in last class about confidence intervals, if you have any questions about that, and then we'll move on to hypothesis testing. Any questions, class, before we move on? What we'll do today, students, is we will spend some time looking at this normal distribution, the traditional bell shape, because this was used extensively with confidence intervals, and we're going to be using it again in hypothesis testing. I think the best way to talk about hypothesis testing is by using an example. So we're going to use an example of some batteries. Let's say that Duracell batteries, they claim that their batteries last at least 2,000 hours. But there are some consumer groups who believe otherwise. So you have some consumer groups who say that it is less than 2,000 hours. Let's introduce some of the statistical concepts. The hypotheses that relates to the manufacturer's claim or the producer's claim is called a null hypothesis, whereas the consumer groups or other groups are referred to as the alternative hypotheses. And these hypotheses are in direct contrast to each other. So we can look at the null hypotheses. Being that the duration of the Duracell battery, they believe that their batteries last at least 2,000 hours. We're using this symbol, population mean. Their batteries last at least 2,000 hours. And the alternative hypotheses, coming from the consumer group, they believe that their batteries last less than 2,000 hours. So now the consumer group, their task is to provide evidence of Duracell's claim. So they go out and take a sample. They go out, let's say they go out and buy 225 Duracell batteries. They put them in clocks or radios and test how long they will last. Let's say that they find on average that they last 1,950 hours. You might think that those numbers are different, so we should believe the consumer's claim because 1,950 is mathematically less than 2,000. But we have to remember that this is not a math class. This is statistics. So we have to determine if statistically the difference is significant. One other number we need here is the standard deviation. Let's say that the standard deviation of the sample is 500 hours. Now let's get into the fun stuff of how we can actually use this data to test if the claim is accurate or not. One of the things we'll have to do first is determine at what level we are testing the claim. We're going to use a level of significance of 0.05. This is a number that a term that we have used in confidence intervals. In confidence or hypothesis testing, this value will be computed to be 1.645. When we draw out the normal distribution, this value 1.645 is going to represent the rejection region. One thing before we can determine if it's on the lower end or the upper end is we have to look at the, let's use a different color here, at this equality sign or inequality sign. It is less than. If it's less than, then we know that the critical region is going to be on the lower end of the distribution, and the critical value is going to be negative. So we can shade in this region. We'll call this region the rejection area. Now the fun stuff, your first calculation is going to be the test statistic, Z. And we've seen this formula in other sections. We take the difference of the sample mean from the population mean, standard deviation, and the sample size. We have all those values there. We can throw them into this formula, and we will get a value of negative 1.58. We look at this value of negative 1.58. Where in this normal distribution is that value going to lie? It's going to lie roughly right around there, outside of the rejection region. So what we can do from this point is, I'm going to move to a different slide, is that we can introduce our rejection rule. We will reject the null hypotheses, or the manufacturer's claim that the batteries last at least 2,000 hours, by looking at this rule. Now I'm going to simplify this rule by using absolute values. So just as a little note, when you are looking at the rejection rule, you use absolute values of Z. It just makes it easier. So we will reject the null hypotheses if the test statistic is greater than the critical value. Our test statistic equaled 1.58, negative 1.58, but for the sake of the rejection rule, we will use absolute values. Critical value was 1.645. The test statistic clearly not greater than the critical value, therefore our decision is going to be do not reject the null hypotheses. So we'll write do not reject the null hypotheses, which means we do not have enough evidence to state that the null hypothesis is not accurate. Perhaps if we had a greater sample size or more evidence, we could claim that the null hypothesis is actually to be rejected. But in this sample, in this testing process, we cannot claim that there is a statistical significant difference between the sample tests and the null hypotheses, or the manufacturer's claim. Questions? Thank you.